Imagine a massive enterprise purchase order. It contains millions of dollars in transaction data, thousands of individual line items, and complex billing codes, all safely stored inside a highly secure, isolated corporate database. This specific order lives on a corporate server running a distinct, localized operating system architecture, like Windows 2000. Now, the company needs to transmit that order to their supplier. The problem is that the supplier's accounting department operates on completely different hardware, perhaps vintage Apple Power Macintosh computers. These two machines do not speak the same native language. If you try to send the purchase order as a raw string of plain text, the destination computer receives a massive, unbroken block of numbers. It can read the individual digits, but without contextual rules, it has no way to determine which number is a price, which is a quantity, or which is a product ID. Wrapping that data in standard HTML doesn't solve the core issue either. HTML tells the receiving computer how to draw a nice visual table on a screen for a human to read, but the back-end inventory software cannot extract numerical values out of that visual layout to actually calculate taxes or update stock levels. To move complex information between incompatible architectures, computer science required a new type of data format. It needed to be universally readable as plain text, entirely self-describing, and totally divorced from visual presentation. The solution to this translation problem is XML, or Extensible Markup Language. It acts as a universal diplomatic format, written entirely in standard text characters that any operating system or programming language can parse natively. Notice how XML's extensible architecture works. Custom tags like purchase order and price wrap directly around raw text, defining every data point. To create order, these tags reorganize into a strict hierarchical tree, mapping exact relationships. Finally, a single root element encapsulates everything securely. Because the structure is so deeply nested and rigidly defined, a software parser can navigate the document algorithmically. It never has to guess if a price belongs to item A or item B, because the hierarchy makes the relationship mathematically explicit. Looking at this data tree, you will find 0 instructions regarding fonts, colors, or visual layouts. This represents a strict separation of content from presentation. By stripping away all aesthetic rules, the XML payload acts as a pure core of raw data. External tools, like XSLT styling sheets, can then take that exact same data core and render it into a web page, generate a PDF invoice, or feed a mobile application. Because this nested system is so precise, a single error can cause severe damage. If a typo sneaks in, or if someone accidentally places alphabetical text inside a number-only price tag, the logic breaks. If an enterprise server blindly accepts that corrupted file, the malformed data can crash the software parser entirely before the application begins processing the order. To prevent these crashes, computer networks rely on schema validation. This is a gatekeeping mechanism that evaluates the structural integrity of every incoming file before executable code touches it. This illustrates XML schema definitions, or XSDs. They act as strict external blueprints, functioning like a glowing filter grid that actively scans the document, confirming tags are in the right order and data types match the requirements. If a file fails the scan, it is rejected immediately. This validation layer upgrades XML from a simple text file into a highly robust enterprise-grade data contract capable of safely running critical infrastructure. Returning to our original problem, that massive purchase order can now move safely across the network. Because it is packaged in XML and validated against a schema, the destination server instantly understands the data, regardless of the operating system it runs on. Today, developers often favor JSON, or JavaScript Object Notation, for agile web development. JSON is lightweight and maps directly to modern programming objects, but it inherently lacks the heavy, rigorous validation rule sets built into XML. That is why XML remains the preferred format for massive, complex enterprise environments. When governments process tax returns, or banks execute cross-border financial transfers, they rely on XML's structural rigor to prevent catastrophic data errors. You will also find XML quietly acting as the invisible configuration backbone for major software environments, managing deployment structures for Java enterprise applications, and routing traffic through foundational SOAP web services. It even governs everyday office productivity. Microsoft's open XML format is the literal structural foundation of modern business documents. It is the reason why standard text and spreadsheet files end with the letter X, like .docx or .xlsx. By providing a strict, self-describing architecture, XML allowed completely incompatible digital systems to finally share meaning, bridging hardware divides to scale the modern internet.